right, welcome. It is, what is it? It's Wednesday, May 20th. This is the infamous D period, Algebra 2. Last day of class. Congratulations, you made it. Wish this last quarter we didn't have what we did, but it's just one of those curveballs you gotta deal with and play the hand you've been dealt. I think it's better than doing nothing at all. Talking with kids and parents who are in public school, so at least it kept some of the learning going, so that we didn't go 5 or 6 months with limited to no education. With that being said, I downloaded the Chapter 6 test from Tuesday. I have not graded them. I hope to grade them tonight, so they should be in Blackboard by, I'll post them by tomorrow morning when I come back in. I don't have a test from Mr. Garcia. Did you submit the test somewhere in Dropbox? It wasn't there a little bit ago. Make sure you do that, because it's got test value, so it can do a lot of repairs or it can do a lot of damages. Hopefully it did a lot of repairs if they were needed. Mr. Parman, did you submit your test?
I'm not sure that I did. I think it's in my notebook though.
Make sure you do, okay?
All right, I'll get that email to you.
Told them after class. You may have already done it since I last checked. Let's see, Cornett's not here. Garcia we talked about. Myers isn't here, right? Myers not here. All right. I have not looked at them. I've got the answer key ready to go, and I think they should be, I structured so I could grade them pretty fast. Mr. Abelhausen, if you can, where did you go? You were here earlier. There you are. Can you take a picture and send me yours again? And be real careful when you, however you do it. The top third of the page, I mean, it's always very gray, but then the top third is kind of blurry or smudged. Can you send it to me again? Because it's that top fourth or fifth is just totally unlegible. Just send it to me in an email, and maybe that will help the quality of it. All right.
I mean,
Mr. Gaffney, did you get my quiz I sent you over email?
Wait, Mr. Bigelow, you're talking all over Mr. Abelhausen.
Oh, I apologize.
Say again, Mr. Abelhausen.
I was saying I can just like zoom in on like the top part and then zoom in on the bottom part.
Yeah, maybe do it in 2 parts if you've got it all. Yeah, that's fine. But I just can't read. It's real gray, and then it's kind of fuzzy, blurry, you know. I don't want to read it incorrectly. Okay.
Okay.
Let's see here. Let me look at my notes. I think that's it. If you looked at Blackboard and saw you're missing stuff or know you're missing stuff, they're real adamant. If you have something that you want to submit, which is fine, I'm not being a stickler on time, and you may lose a few points just because of the lateness, but you know, you may have an M or 2 in there that you thought you were good on, and it maybe got lost in the shuffle here. It maybe was transmitted when Blackboard was down, or maybe you submitted with no name on it and I couldn't assign it. You know, I couldn't make out whose handwriting it is. There's only a few. One of the guys that have real distinct handwritings have I learned over the course of the year. So tomorrow's it. They said no ifs, ands, or buts. If you want to look, see if you got any M's that may bolster your grade just a hair or two. All right. Any other housekeeping chores before we do a little bit on graphing exponential functions?
Mr. Gaffney, did you get my quiz I sent over email?
Let's see. I think I did. Yeah, I'm pretty sure I remember seeing it there, but I'm not sure if I downloaded it. I'm making a note to do that, but I'm pretty sure I did. I will email you if I didn't as I wrap up grades tomorrow Friday. If I'm missing something. All right, anybody else? All right.
I think I have something, sure.
Yeah, I'm working through the stuff now that you've opened the floodgates and figured out how to stuff.
Yeah.
Thanks.
It's a quiz. My quiz 4-6. I have it sent. I just maybe like it.
All right, just make sure I have it in my hands or in my computer by tomorrow. Okay.
Oh no, I already sent it.
Oh, you already sent it.
Yeah, it's
Let me-
4-6.
All right, I'll just make a note. I locate it, and I'll only email you if I can.
Would you want me to re-email it?
No, I'm just making a note.
Okay.
And if I here to make sure I have it, and if I don't, I'll email you to say send it again.
Yes, sir. All right. Thank you.
All right. Any other housekeeping chores? Speaking of housekeeping, so everybody's at their house. Everybody's helping out with chores at home, right? All right. So we're going to graph exponents today. And I downloaded the problem set. It's just one. It's actually 7-1 problem set 1. If you happen to have a printer there and look at it, you can print it out. You're a little bit ahead of the power curve, but I'm structuring as such. If you don't, you just work it out on loose leaf paper, and just trying to find a way to do this that looks instead of me kind of doing it with my mouse pad here. I'm going to actually go to Khan Academy, and he's going to kind of give you a basic overview. And then I think we can, the problem set's got six exponential functions under the graph, and I think we can do, I got 3 on the front side, 3 on the back. I think we can knock out collectively the 3 on the front, and we'll probably stick a fork in it at that point and call it a day and a year. All right. If you want the extra 10 points, let's see, am I recording? Yeah, make sure my recorder's working properly. Sorry about that. I messed up this morning. I did the class twice. What was I going to say? If you want the extra 10 points for the rep grade for the week, I got office hours today and tomorrow at 2 and 2:30. Stop in and say, hello, how are you? And you pick up an extra 10 there if you want that. Or if you've got any questions or want to see how, I'll probably during that time start grading the test. So if you want to check in, I may have had your test graded by then. All right, so here we go. Let's see if I can get Khan to join our little party here. And we'll give it a shot. Let's see here. See if I can get this thing to blow up a little bit. Can everybody see the screen all right?
Yes, sir.
All right, let me see.
Sir.
That wasn't supposed to play, so looks like it was playing while I had it sitting there in limbo.
Equal to 5 to the xth power.
Okay, can you hear him talking all right? Yes? When I
Yes, sir. We can hear it.
There we go.
And we'll just do this the most basic way. We'll just try out some values for x and see what we get for y, and then we'll plot those coordinates. So let's try some negative and some positive values, and I'll try to center them around 0. So this will be my x values, this will be my y values. Let's start first with something reasonably negative, but not too negative. So let's say we start with x is equal to -2. Then y is equal to 5 to the x power, or 5 to the -2 power, which we know is the same thing as 1 over 5 to the +2 power, which is just 1/25. Now let's try another value. What happens when x is equal to -1? Then y is 5 to the -1 power, which is the same thing as 1 over 5 to the first power, or just 1/5. Now let's think about when x is equal to 0. Then y is going to be equal to 5 to the 0th power, which we know anything to the 0th power is going to be equal to 1. So this is going to be equal to 1. And then finally we have, well actually let's try a couple of more points here. Let's try out, let me extend this table a little bit further. Let's try out x is equal to 1. Then y is 5 to the first power, which is just equal to 5. Let's do one last value over here. Let's see what happens when x is equal to 2. Then y is 5 squared, 5 to the second power, which is just equal to 25. And now we can plot it to see how this actually looks. to see how it actually looks. So let me get some graph paper going here. My x's go as low as -2, as high as +2, and then my y's go all the way from 1/25 all the way to 25. So I have positive values over here. So let me draw it like this. So this could be my x-axis. That could be my x-axis. And then let's make this my y-axis. Draw it as neatly as I can. So let's make that my y-axis. And my x values, this could be -2. Actually, make my y-axis keep going. So that's y. This is x. That's -2. That's -1. That's 0. That is 1. And that is +2. And let's plot the points. X is -2. Y is 1/25. Actually, let me make the scale on the y-axis. So let's make this, so we're going to go all the way to 25. So let's say that this is 5. Actually, I have to do a little bit smaller than that too. So this is going to be 5, 10, 15, 20, and then 25 would be right where I wrote the y, give or take. So now let's plot them. -2, 1/25. -2, 1/25, 1 is going to be like there. So 1/25 is going to be really, really close to the x-axis. That's about 1/25. So that is -2, 1/25. It's not going to be on the x-axis. 1/25 is obviously greater than 0. It's going to be really, 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 really close. Now let's do this point here in orange. -1, 1/5. -1/5. 1/5 on this scale is still pretty close. It's pretty close. So that right over there is -1, 1/5. And now in blue, we have 0, 1. 0, 1 is going to be right about there. If this is 2.5, that looks about right for 1. And then we have 1, 5. 1, 5 puts us right over there. And then finally we have 2, 25. When x is 2, y is 25. 2, 25 puts us right about there. And so I think you see what happens with this function, with this graph. It starts off, the further negative in the negative x, the further in the negative direction we go, 5 to ever increasing negative powers gets us closer and closer to 0, but never quite. So we're leaving 0, getting slightly further from 0. Right at the y-axis, we have y equal 1. And then once the exponent over here, or right at x is equal to 0, we have y is equal to 1. And then once x starts increasing beyond 0, then we start seeing what the exponential is good at, which is just this very rapid increase. Some people would call it an exponential increase, which is obviously the case right over here. So then if I just keep this curve going, you see it's just going on kind of this, sometimes called a hockey stick. It just keeps on going up like this at a super fast rate, ever increasing rate. So you could keep going forever to the left and you get closer and closer and closer to 0 without quite getting to 0. So 5 to the negative billionth power is still not going to get you to 0, but it's going to get you pretty darn close to 0. But obviously if you go to 5 to the positive billionth power, you're going to get to a super huge number because this thing is just going to keep skyrocketing up like that. So let me just draw the whole curve, just make sure you see it. Over here, I'm not actually on 0, although the way I drew it, it might look like that. I'm slightly above 0. I'm increasing above that, increasing above that. As once I get into the positive x's, then I start really, really shooting up.
All right, so there's kind of an overview. It's exponential growth. He calls it a hockey stick. They're usually very, oops, hold on, let me go back. Where'd that come from?
This, which is an exponential.
Thank you very much, but no thanks. So I'm going to share the screen and we're just going to collectively walk through. If you're fortunate enough to have a printer, otherwise we could just scratch these out on loose leaf paper. So we're going to just, let me see if I can get some of this stuff out of the way here. I'll make this a little bit bigger. Should be a little better. Okay. All right. So this isn't, it should be section 7-1, not 71-1. Little typo there, my last problem set for the year. All right, so all this stuff here is kind of what he was just talking about. And instead of me reading it to you or just kind of reiterating what's written there, we're going to walk through collectively at least problems one, hopefully problems 1, 2, and 3. All right, so let me let's just kind of do what he did. I can get up to one of these, and I created an XY table, except my table is he's got going vertically. I created this horizontally. This wasn't part of the original problem set. It was just I just did this to create or to help you organize your work, keep it nice, neat, and orderly. All right, so we're going to graph the function y equals 3 times 2 to the x power. So the power, the exponent is the only thing that we're exponentially going to do is that x applies to is to the 2, not to the 3. All right. So if you notice what he used -2, -1, 0, 1, and 2. Right. So I think I'm just looking here on all those are, you know, everything's kind of as close to the origin. So let's just start from the origin and work our way out. And so if it's a little bit of a hit and miss, but it's an educated hit and miss. So if we make x equals 0, all right, we'll just write that in there. So we know, you know, if x equals 0, we're actually talking about what's on the y-axis. And if we plug in 0 for x there, and as he said, and we've talked about in the past, anything to the 0 power always equals what?
1.
1. All right. So 2 to the 0 power equals 1. So it's really 3 times 1, right? So when the exponent x is 0, excuse me, y is going to equal 3. You follow me? Does that make sense? So if we go over 0, and I'm just going to plot these as we go along because I think that then we can kind of relate to it. All right. So if I just arbitrarily then select x equals 1, 2 to the first power is 2, right? And then 2 times 3 is 6. So when x equals 2, y equals 6. So we come over 1 and go up 6. It's 3, 4, 5, 6. All right. So I can't write too precisely with this. So let's do, let me see my notes here. Let's do -1 and see what that does for it. All right, so -1, remember if I have, let's just do it over here. If I had 2 to the -1 power, right? We take the reciprocal, which makes that exponent positive, right? So 2 to the -1 power is equivalent to 1 over 2 to the first power, or also 1/2. Look familiar? Sound familiar? Make sense? So when x is -1, y is 1/2. So -1 is here, 1/2 would be right in the middle. All right, so let's do +2. If x is positive, that's 2 times 2 is 2 times 2 is 2, or 2 squared is 4 times 3 is 12, right? Let's see here. So we got 2 and 12, which is going to, I didn't adjust my scale on the y-axis, which I probably would have been a little bit wiser to make every box worth 2, but it would be that 6 there. It would probably be right up in, you know, somewhere in this general vicinity. All right. Or I could have, you know, adjusted my scale on a y-axis like he did. All right. So let's see if I make x equals -2. All right. That would be the same as 1 over 2 squared, or 1/4 times 3. So this would be, let's see here. This, come back in. I lost my pen here. I can go back and correct something that I told you incorrectly. Let's see. Is that all right? Yeah. So let me finish this one up. I'll go back and fix what an error I told you. So if I had 2 to the negative 2 power, that would be the same as 1 over 4th, right? It'd be 1 over 2 squared. Times that 3 would make this 3/4, right? So negative 2 and 3/4. So that would be negative 2 and 3/4. That's one to be right about here, all right? Let me go back and fix negative 1, all right? And we talked about negative 2 to the negative 1 power is the same as 1/2, all right? I've got to multiply. I did not multiply that 1/2 times 3. So negative 1, the point is technically negative 1 and 3/2. So let me fix my little error, all right? So it'd be negative 1 and 3/2, which is the same as negative 1 and 1.5, right? So this is what that exponential function graph would look like. Does that make sense? Little jiggly lines a little bit, all right? Questions? All right. I'm gonna do. Why don't I get you started? And I'm gonna do 0. I'm gonna do 0, 1, and -1. I'm gonna let you do 2 and -2. Okay. All right. So if we plug in 0 for here for the x, we get 1, right? So if the x is 0, then y is 1/3, right? Because 3 to the 0 power is 1 times the 1/3. Agree? So if I plot that, it's over 0 up 1/3, be right here near the origin, okay? I plug in 1 for x, right? 3 to the first is 3. 3 times 1/3 is 1. So I've got 1 and 1. Keeps things nice and simple, okay? If I do -1 here, I've got 1/3 actually times 1/3, right? So if x is -1, y is, oops, that's a positive, it's not a negative. It's 1/9. And you can see just because of the scale of our graph, it's hard to get it real precise, but of course it'd be just above the x-axis. All right, I'm going to give you a minute. Even if you don't have graph paper, I'll help you graph it on this. Calculate what y would be when x is 2 and -2. All right, I'll give you 30 seconds or a minute to figure that out. Okay, so let me walk through it with you. Let's see if we agree. Okay, so if x is 2, okay, we're saying 3 squared. So 3 squared is 9 times the 1/3. So when x is 2, y is 3. Oops, I wasn't doing that. See, so it's right there. Disregard that. Oh boy, it's right here. All right. If x is -2, that would be 1 over 3 squared, right? Well, 1 over 3 squared is 1/9, right? Times the 1/3. So when it's -2, it's 1 over what? 27. Is that right? I think so. Okay. So let's see. We're getting super, super close, just like in his example of the x-axis. All right. Let's just for giggles, let's see what 3 would do for us. All right. Just because we got room, it may be on the graph, it may not. So if I got 3 cubed, 3 cubed is 27, right? 3 times 3 is 9. 3 times 9 is 27, divided by 1/3. So when x is 3, y is 9. So That's 3, that's 6, that's 8. So it'd be right up in here off the graph. Right. So we got, 5 points should give you a fairly decent representative accurate graph. So it's going to look something along these lines, fairly similar to that first one. Make sense? Questions? Comments, concerns? All right. So, if you don't have graph paper, that's no big deal. Why don't I have you complete the table? Go 0. Let's see, what do we want to do here? Let's go 0, 1, and 2, and then -1 and -2. I'll let you come up with the values. Let's see if we can hopefully agree on the y values when x is 0, 1, 2, -1, -2. Okay? Give you a couple minutes, and we'll talk about it. Excuse me. You guys with your cameras off, you're not sleeping on me, are you? Mr.
No,
Lingo,
sir.
Melendez, Landis, Miles,
Nope.
Cliff.
I'm
No,
awake.
sir.
Are you not watching The View or SpongeBob SquarePants or something like that, right? Okay, how do we do? So if I plug in 0 for x, that means 5 to the 0 power is 1. So the y is going to be 0.25, right? If I plug in x is 1, I'm trying to see if I can do it in either way. X is 1, it's basically 0.25 times 5, right? And hopefully you came up with 1.25, right? Oops, it's too big. Let's see if I get a smaller font. So let me do that. I don't think it will. All right, get that idea. If x is 2, I get 25 squared is 25 times the 0.25. And let's see here. I get, come on, pen. I get 6.25. I can't get my pen to operate, and I can't get a smaller font on the typewritten, so I'm just going to put it below it. Okay. So 0 is 0.25. When x is 1, it's y is 1.25. When x is 2, y is 6.25. When x is -1, we get 0.05. When x is -2, we get 0.01. Okay. Hopefully you got those values. Now let's see if I can graph those. All right, so if I got 0 and it's 0.25, that's basically 1/4, which is right there. If I add 1, it's 1 1/4, which is about right there. If I get 2, I get 6 1/4. It's 3, 6. That's about right there. -1 is 0.05, which is right, gosh, it's right above the x-axis. And 2 is 0.01. That's pretty much on the x-axis. So if we would graph it, it would look something along those lines. All three of those graphs you can see are basically the same shape. So so that's basically it. You want to try any more? You want to? Let me just let's do one more. We got time. Give me a second here to clear my scratch here. Okay, and let's see. Got to turn that off. And I like number 5 on the back. All right, so we're going to do number 5, and then we're going to put a fork in it and call it done. All right, so let's do this. I'll tell you what. Yeah, let's. We'll have you do it. Let's use those same 5x values. 0, 1, 2, -1, and -2. Okay. So you're going to calculate y for those 4 exponential values. And I'll give you a minute or two. We'll graph it, and then we'll kind of have some parting remarks. Let's see if I can make this do something. Let's see. All right, how do we do? So if I plug in, I plug in 0 for x, I get 1 minus 2, right? Because 4 to the 0 power is 1, so it's 0. Oops, let me get my pen back working. It's 0 and -1, right? Hopefully everybody got that. If I plug in 1 for the power, so at 4 to the first is 4. 4 minus 2 is 2, right? If I plug in 2 there, I get 4 squared is 16. 16 minus 2 is 14, right? And then here's where it gets tricky. If I plug in -1 there, that becomes 1/4, right? To the first power. So 1/4 minus 2. 1/4 minus 2. I'm going to put it down here because I can't write that little. So 1/4 minus 2 leaves me a -1 3/4. You got that? You're doing great. Okay. Now, if I plug in -2 here, I get 1/16 or 1/16. I subtract that from 2. I'm going to just put it over here. I get 1. Let's see, 1/16 minus 2 is 1 and what? 15/16, I believe. We're going to graph that. It's going to be interesting. Okay. 1/1 and 15/16. Or what would that be? 31/16. All right, so let's just graph and see what it gives us. So if I go over 0, over 0, and I'm down -1. So that's right about, oops, I'm sorry. I looked away and marked the pin. So it's 0, -1 is about right there. Over 1 up 2 is right there. 214 is off the charts. I got -1 and -1 3/4, so that's almost down to 2. So that -2 kind of becomes my threshold line instead of the x-axis, like as it was in those 3 on the front side. And -2 is 1 over 15/16, which is even a little closer to that y equals -2. So if I connect the dots, it's going to look something like that. Okay. All right, questions? Like I said, you might want to just print this out. If you want to mess with those other two, that's fine. Just to kind of give you a taste of it, because you will do some of that in pre-cal. I'm not exactly sure when in the calendar year. It might be kind of thinking just based on watching what Cam and then Ms. Stolmich did this year. I think it's probably right after the holidays, like January, February. So at least you've got a little bit of exposure to it when you see it again. All right, with that being said, I just want to say I appreciate you guys having you in class this year. I'm sorry for all of us, that this D period is, or not this D period, but this fourth quarter has been trying and challenging in more ways than one with the current situation. And I appreciate, it'd been a lot easier just to kind of disappear into the weeds and quit doing the work and not showing up. Appreciate you kind of keep grinding and us keep moving forward, not at the pace and at the level that we would like to, just because this is not as efficient as having you guys in the classroom where we can interact. You can get back quizzes and tests and homework assignments so that yeah, I've got this material down, or no, I don't, or quiz retakes and second and third chances, and I can do a little pushing, pulling, and prodding when you're not turning in homework. Which is hard to do in this type of environment, but still can be done. But appreciate you, hanging in there, particularly this fourth quarter. I'd say good luck this summer. Stay healthy, stay safe. Maybe you'll see some of you. I think our graduation is tentatively planned for July 11th for the seniors. So hopefully see some of you maybe at that joyous time where we can kind of get back together again in person, as opposed to looking at a Brady Bunch screen of a bunch of students. And I'll be glad to open it up for anybody else wants to have any parting remarks for their fellow classmates, or any other comments or critiques or questions.
Yeah, I just want to say I joined late because I'm not even home right now, sir.
Okay.
I'm at my cousin's house. There's some family stuff going on, so I couldn't be home.
All righty.
And then most of my work, have you graded my assignments? I haven't been able to check because I haven't really been home.
I haven't gotten anything from you to grade.
I sent you my quiz, and I had a mission for it, the quiz from the beginning of the week.
You might want to resend it, because I don't believe. Let me go back. Check.
I'll just resend everything to you today when I get home on my laptop and stuff. I'll send you an email. And then, do you still have office hours?
2 to 2:30 today and tomorrow, and then Friday's a holiday for us. Like, probably, I guess you guys too.
All right, so I'll be there. I'll talk to you.
Okay. All right. Anybody else?
See you, Mr. Gaffney.
Yes, sir.
All right.
I had a good year, Mr. Gaffney.
Good.
Stay safe.
Good thing. Hopefully, Mr. Big will
Gaffney.
be back here next year. That's what I'm counting on.
Yeah.
All right.
Sure.
All right.
Good luck. If you need to check in or want to pick up an extra 10 points, office hours 2 to 2:30 today. All right. All right. Everybody be safe, and we will see you. Over and out. Any questions for me?
Oh, so I had a
Go.
question.
Yeah.
Could I do like the thing from 2 to 2:30? Could I just get the points now? Cause I was gonna come in, but I have a driver's ed thing.
Driver's ed thing.
Yeah. I just when I was gonna come in, I was gonna ask if you knew if I had any missing work, because I know I turned in the one that was missing, but
Let me do a quick, take me 30 seconds to look back through. See. There'd be an M there if you have anything missing. So far, I haven't found anything. Let's see. Still looking. Still looking. Nope, you're not missing anything from my record.
okay.
I mean, on Blackbaud, because I could inadvertently, make a mistake, or the thing jumped or hiccuped when I was inputting grades, and you inadvertently got an M or something. But no, there's no, in my paper grade book, you got everything.
Okay. Thank you.
All right, and I'll honor your request that you gave me earlier. Okay.
Okay. Thank you.
All right, drive safe.
All right. Thank you. Have a good summer.
You too.
Mr. Gaffney,
Yes, sir.
for my missing work, when I click on the worksheet, it doesn't show me like the questions.
All right. Why
It
don't
shows
you?
it shows me like different numbers and shows me letters and empty blanks.
Okay, so why don't, can you either tell me or email me the problem sets that you want over, and I will convert them to a PDF as opposed to a Microsoft Word document, and see if that has been correct in the problem when I convert it to a PDF document as opposed to a Word document. But you got to tell me which ones. The best is if you would just email me and say, hey, I need these quizzes, give me the section number, or these homework problems, give me the section in the problem set number, and I'll convert it to a PDF and I'll email it to you as a PDF, and we'll see if that fixes it.
Okay.
Okay?
Thank you.
All righty.
Okay. Have a good summer.
All right, make sure you do that today, preferably, so you can get it done and get it to me tomorrow.
I will.
Okay. All right, we'll see you.